Hello, and welcome to another episode of AI in the Classroom Daily, a podcast helping educators make sense of AI without the hype. Full disclosure, I use AI as a thinking partner in preparing each episode because the best way to talk honestly about AI in education is to work with it openly. I'm Dan Cogan-Drew, co-founder, chief academic officer here at Newsela. Back in the 1980s, the Stanford scholar Lee Shulman introduced the idea that great teaching isn't just about knowing your subject, and it isn't just knowing how to teach. It's knowing how this particular content might trip up these particular students in this particular moment. That's hard-won, specific knowledge that separates, let's say, a brilliant mathematician from a brilliant math teacher. It's the concept that Shulman introduced known as pedagogical content knowledge, or PCK. Last week, the Learning Agency published a 5 questions piece with Andrew Lan, a professor at UMass. Lan is trying to build AI systems that simulate student thinking. And what his research reveals is just how much PCK is still missing from AI. So I want to talk a little bit about the 3 implications that I think arise from the interview with Lan. 1, it helps us understand the nature of the jagged frontier of AI, what Ethan Mollick calls the jagged frontier, because of the unevenness in the advances that we're seeing in the AI. This is something that AI cannot do. What Lan is describing in his work is his surprise that simulating student errors is far harder than expected. LLMs prompted to act like struggling students don't behave like real struggling students. That may be a technological problem in terms of the AI, but I think fundamentally it's a pedagogical content knowledge problem. A teacher with deep PCK will know this because they will have had years of experience working with students as they're getting tripped up and understanding which misconceptions are predictable, which errors are random, and how to address these. AI doesn't have that. It can generate content, but it doesn't understand what it means to not understand something. That's point 1. Point 2, to go back to a previous episode, we were talking about a report released by the Brookings Institution back in January. And one of the points that it made was that there's real danger in the way that AI literacy is being taught. The emphasis that AI literacy is putting on tools as a form of building literacy about AI is getting things backwards. The comparison that the report made was to teaching students at great length how to use the microscope in a biology lab, but not taking the time to help them understand the fundamentals of biology itself. And that increased emphasis on the tools doesn't teach us anything about the underlying technology. And what's of great value in Lan's work is that it's helping us understand something about AI, setting aside individual tools. And the reason I think that we're seeing a lot of AI tools underdeliver is that they're operating absent that PCK. They know content because they've been trained on the internet, and the internet is filled with content. They may even know some pedagogy because they've been fed models of good pedagogy. But they don't understand how that content and that pedagogy intersect with a student learning experience. So they don't know how to anticipate, to diagnose, and to properly address how a student might misread a proportional reasoning problem, or a student who might be highly proficient in decoding might still stumble on inference. And the simulated student work problem that Lan is working to solve is an attempt to try to build a kind of synthetic version of pedagogical content knowledge. And the point here is that's really hard. And that's something that should be kept in mind when evaluating EdTech products today. And then I would say the third implication here is for teachers. You can imagine teachers would find value, or the developers of products would find value as well, in using simulated student agents to practice. So I recall from my own experience learning too late that the essay assignment that I gave to my students produced fairly mediocre essays, and that the direction we were moving in was not going to be a productive one. If I could have simulated what different types of student writers might have done in response to one of my writing prompts, I might have been able to do a dry run, so to speak, of a number of different approaches to the topic until I found one that gave me the range and depth that I was looking for from the student responses. I think that you could apply that similar logic to the idea of the coach that we were talking about using the tennis ball serving machine as a tool to help them increase the number of repetitions in their tennis lesson. They understand when they're using that tool how it's going to create additional repetitions and what they're likely to see in those repetitions. And I think that's a really valuable thing to be able to simulate, is to say, if I use the tool in a certain way, what will the effect be? And to be able to do that with enough confidence that you're actually predicting how this will play out. Because the time that you have with students is so precious, often you want to rewind that lesson because you realize something in the process of teaching it, or you find in your third period of the day teaching the same lesson, you now understand the right way to teach it. If you could rewind the clock and get to that third period understanding in the first period, you'd be that much more advanced in your instruction from the beginning. So 3 practical takeaways, just to reiterate here. Pedagogical content knowledge is the frontier, and that jagged frontier that Ethan Mollick talks about. AI has not reached that effectively. There is need for public data sets, as the Learning Agency has been saying. That's really at the core of what's holding up Lan's work, and the ability to develop that pedagogical content knowledge is contingent upon having that kind of large data set that can be used to evaluate and train new models. But I would say the third point, and maybe most optimistically, is that Lan understands this. This is someone who understands the domain and the terrain in which they're working, and they see the space for what it is. The product of the efforts here is going to be genuinely useful because it's going to create the ability to do that kind of simulated instruction in advance of instruction and test out new ways of thinking. So, to wrap it up, Shulman's insight was that PCK can't be assembled from different parts. You can't take a content expert and add pedagogy classes and arrive at a great teacher. The knowledge that lives at the intersection is its own thing, and that's built through experience with real learners. I'm telling you this, if you're a teacher, you already know this. And that's what makes it so hard to encode in AI, and that's what makes it so valuable to protect in teachers. So the good news is the work is being done. It's being done openly and honestly about where there are strengths and weaknesses, and there's great promise in the result. Thanks for joining, and I'll see you next time.